Okay, chapter 3 of Math 1270 deals with linear functions and graphing them. And so I'm going to start off with the function. If you want to graph a function, the easiest way is to have the function in what we call slope-intercept form, where the y is by itself. Okay, so if you have a function where y is not by itself, okay, we talked about this as well, and this one was in standard form. If you want to graph it, you want to get that y by itself. So get rid of that x term and get rid of that coefficient and rewrite it so that it is in slope-intercept form, because whatever number is in front of the x is slope. Let me talk about that real quick in blue. So there's several ways to talk about slope, and you need to be familiar with all of them. If we had two ordered pairs, we can figure out the slope by using that formula. And the most important one, and I believe that students forget, is how to, if it's graphed, or if you want to graph it, how do I know whether to go up or down, left or right? Okay, well, since the y's are on top, that's your ups and downs. All right, so if the number is positive, we go up, negative, down. Run is your left and rights. Positive right, negative left. Very, very important to remember that as we go to graphing these here in a little bit. Now, in green is the y-intercept. So whatever number's on the end is y-intercept, and that's where it crosses the y-axis. Now, let's just go ahead and draw that and talk about that y-intercept in more detail. If you look at the y-axis, okay, we have all the ordered pairs would be when x is 0, because we don't go anywhere on the x. We just go up or down. So my point is, the reason why that number on the end is the y-intercept is because if you put 0 in for x, let's draw a little arrow here real quick. If I put 0 in for x, okay, 0 times anything is 0, so you're just left with y equals 3 anyway. So if I'm graphing y equals negative 2/3 x plus 3, I know automatically that's going to be one ordered pair. Okay, well the negative 2, 3, okay, since it's a negative slope, just write this over here, you can put the negative with the top or the bottom, just as long as you don't have two negatives, because then that would turn it positive. All right, so you can go down to right 3, okay, or you can go up to left 3. And the way that I wanted to mention to you guys there, negative slope is downhill. So as I walk from left to right, I'll be going down the hill if it's negative slope. All right, so that's that one. And if I did negative 2x plus 5, we'll just go ahead and do that one all in green here. You'd have a y-intercept of 5, and then this slope is also negative. So negative 2, 1, or 2, negative 1. So down to right 1, or you can go up to left 1. Okay, and then again, it's going downhill because it's negative slope, so up 2 more. 1, 2, left 1. A little bit steeper, as you can see. Okay, and there's that one. So if you have positive slope, we'll talk about a positive slope here in a second, it's going to be going uphill. But the main thing I want to point out, if you want to graph a function, you want to write it in what we call this slope-intercept form, which is where the y is by itself. Okay. Next, real quickly, you'll have just a couple things you might have to graph ordered pairs and tell what quadrant the ordered pair is in. Okay, well, quadrant 1 is in the top right, and then it goes counterclockwise. Very important fact not to forget. Those are easy ones. So like this ordered pair right here, okay, is 3, 1, because the x is 3 and the y is 1. All right, so that's in quadrant 1. This ordered pair here, okay, x is negative 3 and y is 1, 2, 3, 4, 5, 6, it looks like. Okay, or actually probably 5. All right, but my point is that ordered pair is in quadrant 2, etc., etc. Easy questions. Now, if you, I'm going to go back to that same function, 2x plus 3y equals 9. Okay, I'm going to actually squeeze it in right here so I don't lose its graph. Another way to figure out and graph 2x plus 3y equals 9 without getting y by itself is just to find 2 points real quickly and the 2 points being the x-intercept and the y-intercept. So just like when the y-intercept, x is 0 because you're not going to go left or right, same goes for x-intercept, y is 0 because you're not going to go up or down. So if you plug 0 in for y, you're just left with 2x equals 9. You divide that by 2, and you get 4.5. So this 4.5, I was a little off. I just rough sketched it. Okay, so it should have been over here. Or my increments are way off. Right, so so there's 4, maybe 4.5. So this is just where it crosses the x-axis. So it's an ordered pair. 4.5, which is 4.5 to the right, and then nowhere up or down. Same goes for y-intercept. I'm going to plug 0 in for the x. So 2 times 0 is 0, so you're only left with 3y equals 9, and then you divide by 3. Okay, and again, now you have that ordered pair. Don't go anywhere left or right, just go up 3, and we already knew that one. Oh, I thought it was the green line. Okay, I guess I was a little bit more accurate. Okay, the black line is this function. So the y-intercept is 3, and then there's your 4.5, which isn't so far off now that I look at it. So don't forget those shortcuts as far as intercepts go. Also, next is if you have a function that is already graphed, what is its slope? And then if you just got 2 ordered pairs, what is its slope? And then we got to talk about parallel and perpendicular lines real quick. So again, if you have an ordered pair, 2, 3, 3, 4, okay, and you wanted to find its slope, you just got to do the slope formula. So we do 4 minus 3, and then 3 minus 2, and I get 1. So again, just label first order pair, second order pair, and then do your y2 minus y1 over x2 minus x1. The only part where students mess this up is if you have a back-to-back negative. So if I had a negative 2, say, all right, so therefore I do 3 minus a negative 2, which then means I would add, and then my slope would be a fifth. So just watch the double negatives when doing those. Also, another part is we'll find the function that goes through a certain point and has a slope. So let's say they tell you the slope, and they say, well, you have some function with the slope of -3, and it's going to go past a point, maybe -1.5. 2 ways of doing it that we taught you in class. You can just do the slope-intercept form, or you can do point slope. Most students just went straight to point slope, as long as you realize you got to substitute in all 3 things. You got to plug in your slope, okay, and you got to plug in an x and a y. So when the input is -1, you get an output of 5. So then you can figure out what the y-intercept is to write your equation. So y-intercept is 2. Once you know the y-intercept is 2, write the equation, y equals -3x plus 2, and you're done. You would get the same thing here if you did substitute your y1, substitute your x, or your m, sorry, and then substitute your x1. Watch for the double negative there. Okay, x plus 1. Then distribute, so -3x minus 3, and then add your 5, and you get the same thing in the end. So just don't forget those processes, as you'll be required to do those. And last but not least is parallel and perpendicular lines. If you have parallel line, then the slopes are the same. If they're perpendicular, then the slopes are opposite reciprocal. So say that you are given a function like y equals -1/5 x and plus 6. And you say, find the function that is parallel. So find a function that's parallel, right, to this line and goes through some point to -1. So knowing that if something's going to be parallel, the slopes have to be the same. So all we're really interested in is, well, if that slope's negative a fifth, then this slope, I'm going to stick to slope-intercept form instead of point slope. Then this slope has to also be negative 1/5. Okay, and then you take this ordered pair, just like we did before, and we plug it in. So when the input is 2, I get an output of negative 1. And we can see what the b is and write the function. Now, so we got negative 2/5, then we add 2/5. So negative 1 plus 2/5. Okay. Okay is negative 3/5. Okay. So then you can write your function. Y equals negative 1/5 x minus 3/5. So this function is parallel to this line because they have the same slope, and this point is on that line. And you could check your work just like with anything function wise. All right, do I get negative 1 out? Yeah, negative 2/5 minus 3/5 is negative 1. So good answer. Now here's the last thing I need to make. If they say find a function that is not parallel but perpendicular. Something you need to know about perpendicular slopes is that, and we talked about this too, is that they're opposite reciprocals. I'm going to make a little abbreviation here. Well, I'll just spell it out. So opposite reciprocal. Okay, opposite means it changes the sign. So if it starts negative and I take the opposite, it will turn positive. If it starts positive, it turns negative. Reciprocal means you flip it. So 5/1. So it's just 5. So instead of using negative 1/5 here, okay, process would be the same. You would just use 5, which means this is now 5 times 2, which is now 10. Okay, which means you're now going to subtract 10 from both sides, and you're at negative 11. So your function would be y equals 5x minus 11, because now this line and this line are perpendicular to each other because the slopes are opposite and reciprocals of one another. And then this point here is a solution.